The first thing that we're going to do is we're going to talk about the idea of slope. So remember I told you guys when we were talking about constant rate of change, CRC, I said that that was also known as the slope when we're talking about a graph. So as you are consistently rising and then consistently running, those would be your change of your y's and your change of your x. So that's what I'm going to go ahead and identify to you guys right now, that when we talk about the rise, so I'm going to circle rise in my blue because we always did change of y in blue when we were talking about it. So that is our change of the y value. That is our rise. Okay, and then our run, I always did that in the pink, or the change of the x in pink. Okay, so that is going to be located here. That is known as our change of our x values. Okay, so again, like we said before, that the slope and constant rate of change, those are identical when we're talking about them. They are very much interchangeable. And again, constant of proportionality is equal to your constant rate of change when it is a proportional relationship. Okay, the constant of proportionality is going to have a constant rate of change that is equal to the proportionality of each point. Okay, though they are not interchangeable to be called slope. But constant rate of change, slope, they are interchangeable. And there's very important things that you need to make sure that you keep in mind when we're discussing the rise and the run for slope. So again, I'm going to go ahead and highlight the rise in my blue, the run in my pink, so that way you guys know whenever we are working it out on a graph, you will know that I'm always talking about my rise and my runs based off of my colors. So point number one that's really important is that slope is mainly presented as a fraction. Sometimes you'll have it written as a decimal, but the majority of the time it's going to be written as a fraction. Okay, hence the reason it's rise over run. And again, we do not do mixed numbers. We do not do mixed numbers. There's no value that's going to be written in the front. It has to be an improper fraction or proper fraction because it has to be rise over run. So slope is mainly, not always, but mainly presented in fraction form. Okay, and then the other important thing to understand, it's like kind of like a GPS. You guys know GPS, right? If you're trying to figure out where to go when you are leaving your house and you're trying to get directions to go somewhere, your GPS gives you those directions. It tells you to turn right here, turn left there, keep driving, however many miles. It's the same thing with slope. Slope is going to be a direction that you are moving from one point to the next point on your graph. So slope is a direction. Bless you. From one point to the next. Okay, so if we graph a point and then the rise and the run happen to be 4 over 3, then we would go up 4 and then to the right 3, that would take us to the next point. And then we would go up 4 and to the right 3 again, that would take us to the next point. And then up 4 to the right 3, and that would take us to the next point. So it keeps telling you where to go from point to point to point. Okay, so slope's not always going to be just from a graph. Sometimes slope is going to be from a basic situation. So here we have a treadmill that extends 30 inches in width with an 18-inch incline. So we want to know what the slope is going to be. So again, slope is always going to be written as my fraction. So I'm going to go ahead and set my fraction part up. I know that my rise is going to have to be on the top and that my run is going to have to be on the bottom. So again, rise, guys, means that you are going either up or down. Okay, I know that rise always makes us think that we're just going upward, but the direction that it could be moving is up or down. The run is always going to be moving to the left or to the right when we're thinking about it graphically. Okay, so that means that our run is going to be this measurement here, and that our rise is going to be this measurement. Okay, so which one of these is going to represent the rise here? Is it the 30 inches or the 18 inches? Sebastian? 18. 18 inches is going to be our incline, so that is how far up we are going to be moving. Okay, and that means that the 30 inches, which is your width of your treadmill, that's going to be your run. Okay, so we're going to be filling this out as 18 over 30. And then like always, we want to make sure that we can simplify them. You must always simplify your equation, or sorry, your fractions. So they're both divisible by 6. That would simplify to 3 over 5. And that would be our slope. Okay, if we're taking a look at problem number 2, a hiking trail rises 6 feet for every horizontal change of 100 feet. We want to know the slope. So that one's pretty easy. They told us already the rise. It's going to rise 6 feet. So I can put the 6 on the top. And that it's going to be for every horizontal change. The horizontal change is the same thing as your run. So it's going to go on the denominator, 100. Okay, so again, we always put the rise on the top. I'm just going to set it up for you guys to just so you know again. Run on the bottom. And then we simplify. They're both divisible by a maximum value of 2. So that can simplify to 3 over 50. So our slope would be 3/50. All right. So again, just like we watched the video with Slope Dude, these are our types of slope. So we have our positive slope. Positive slope, reading from left to right, it shows that it is going uphill. Okay, like I told you guys before, when we read a graph, we always start from the left side and read it to the right. We don't start from the top. Okay, you start left to right. So this is going to be our positive slope. So puff, puff, positive, puff, puff, positive when he's going uphill. Okay, when you are reading from left to right, you are going downward. That is our negative slope. So that was that nice negative that he talked about. Okay, then when you get to your horizontal flat line, a horizontal flat line is going to be 0 fun. So we call that our 0 slope. Okay, and then we've got our vertical drop. A vertical drop is going to give us our undefined slope. Okay, and then the reason for these being labeled positives, negatives, 0, and undefined, let's go ahead and talk about those real quickly. So for positive slope, if I pick any point on here, let's say I'm picking this point to this next point, I would have to go up, and then I'd have to go to the right. I would have to go up and then to the right. Up is a positive value, right is a positive value. So when we have a positive over a positive, that gives us a positive. Okay, when we're looking at our negative slope, let's say that I pick this point and I'm going to this point. I'm having to go down and then to the right. So going down and then to the right means I'm dealing with a negative over a positive. A negative over a positive is going to give me a negative. Now for 0 slope, again, if I pick this point to this point, I do not have any incline. So I'm not moving up and I'm not moving down. That means that I'm moving 0. But then I'm going to go to the right, which is a positive. So 0 over any number. Check it out on your calculators. If you do 0, oops, let me clear this all out. If we take 0 over any number, let's say we put it over 5, it's going to give us a 0. Okay, I could put 0 over 28. It's still going to give me 0. I could put 0 over a negative 19. It's still going to give me 0. Okay? It does not matter if 0 is your numerator, meaning your rise happens to be 0, then your entire slope is considered to be 0. Now when we get to this undefined part, it has the opposite effect. we do not have a run this time. We have a rise. Okay, we're decreasing or increasing, depending on how you want to look at it, because it doesn't matter from left to right. You could be going up, you could be going down. So we'll just say we're going up. We're increasing, but then we have 0 for our denominator. So that's going to be a little bit different. Any number that you take, like let's say, again, we have a 5, but this time we put it over 0, so 0 is our denominator, we're going to get an error message. You have a divide by 0 error. You are not able to divide by 0. 0 cannot be a denominator, which is why we call it an undefined slope. Does everybody understand? Okay, fantastic. Let's move on to the next. All right, flip that over. Taking a look here, graphically we are trying to identify what the slope is going to be. So that means that we do first want to identify the type of slope. So taking a look at problem number 3, what type of slope do we know what we're dealing with? Positive, negative, 0, undefined. Oliver? Negative. So I'm going to go ahead and write up at the top that I know at least I'm dealing with a negative slope. So that means that I need to make sure that my slope has a negative answer in it. Okay, so now all I have to do is pick 2 points on the graph. 2 points on the graph. Now remember, when we're picking points, we need to make sure that we are picking points specifically that are going to cross over the grid at a perfect position. So for example, I would not pick my point to be right here because that's not perfect positioned. I need to pick it to where it crosses that grid mark. See, the grid marks each intersect at a specific spot. You want to make sure that your line is crossing over one of those specific spots. So like I could pick right here at 0, 3. And I could also pick like right here at 4, negative 3. Okay, these are both very specific spots that I can pick. And then from here, I would just identify my rise and my run. So for my rise, I need to count how many units downward I have to move. So I'm moving 1, 2, 3, 4, 5, 6 units downward. Again, we are moving down, so that would be a negative 6 for the rise. Okay, then for our run, from where we left off, how far to the right are we going to be moving? So we are going to move 1, 2, 3, 4 units to the right, which is a positive 4. So that means that our run is going to be a positive 4. Okay, and then of course we always want to make sure that we simplify it. They both happen to be divisible by 2. Now because I do have a negative, I don't have to associate the negative just to the rise. I can go ahead and place the negative inside, or I'm sorry, on the outside of my fraction and just put 3 over 2. Now here's the reason that I'm telling you this, because when you are graphing it, it can go in either direction and it will still be able to create that point. So what this means is that negative sign can either belong to the 3, which means you would be graphing it down 3 and then to the right 2, or you could assign the negative sign to the 2, which means you would go up 3, but then you would go to the left 2. Okay, so if I were to start at this point here, let's say I go down 3, 1, 2, 3, and to the right 2, 1, 2. Does it take me to a point on my graph? Yeah. If I do the same thing from this point and I do the reverse, I go up 3, 1, 2, 3, and then to the left 2, 1, 2. It'll take me to that point. Okay? So these are the directions that you can move. You can move in opposite directions. That negative sign is not necessarily only belonging to one of the numbers. It can belong to either or. Okay? It's important to make sure you understand that. All right. Go ahead and do problems 4 through 6 on your own. Identify the slope. Okay, what is the slope for problem number 4? Who can tell me what the slope is going to be? John Luke? And what is the actual slope? You had to tell me the actual. Thank you, 2/3. Okay, so it is a positive. We do know that we're dealing with a positive value here because it does have the increase that's happening. Again, you can pick any 2 points within the graph. So I would go ahead and pick a point right here at a -3, -3. And then I would pick another point. We can go right here at +3, +1. Okay, those are both valid points to be able to pick. For the rise, we happen to be going up 1, 2, 3, 4. So that is a +4 that we are increasing by. And then for the run, we are going 1, 2, 3, 4, 5, 6 to the right. So that is a +6 for the run. And again, we are going to go ahead and simplify those to 2/3. Now, again, the fact that they are both positive, that means that we can either go up 2 and then to the right 3. A positive over a positive makes it a positive slope. Or we can do the direct opposite. Go down 2 and then to the left 3. That would be a negative over a negative. A negative over a negative is also a positive. Okay, so you have to keep in mind that you are able to move in both directions. All right, what about for problem number 5? What kind of slope are we dealing with for problem number 5 here? Huh? What slope are we dealing with for problem 5? What's the slope, Sebastian? Undefined. We are dealing with an undefined slope here. Okay, it is a vertical graph. It is a vertical drop, so that means it is an undefined slope. And then for problem number 6, what is the slope for problem 6? Angeline? 0. Okay, we are dealing with a 0 slope because it is a horizontal flat line, so 0 slope to there. All right, go ahead and flip it. Slope is not always just found from graphs, but we can also find it from tables and from just being given specific points. So taking a look here, again, if we are talking about from a graph, the run is going to be how are we changing with our x values. The rise is going to be how are we changing with our y values. Okay, so for this first one, we happen to be increasing by 2 every single time when it comes to our run. Our rise happens to be decreasing by 3 every single time. So when we are talking about our actual slope, the rise has a change of -3. The run has a change of +2. So that means we're dealing with a -3/2 for our slope. Go ahead and do problem number 8 on your own. All right. What is the slope going to be in simplest form, Jeremy? 1/4. Good. Okay, so again, your run happens to be here with the x values where you are going ahead and increasing by 4, then you're increasing by 8, and then you're increasing by 4 again. That's perfectly fine that you have a different change that's occurring as long as that change is consistent, you know, when you are in simplest form. For the y value, you were increasing by 1, then you increased by 2, and then you increased by 1 again. So when we're looking at it, we have a change that has a rise of 1 when we had a run of 4, and we also had a rise of 2 and a run of 8, and they both happen to be simplified to the same thing, a +1 over a +4. Okay, they both simplify to the exact same value. All right, the last thing that we're going to be discussing here is the actual slope formula. So our slope formula is when you are not given the actual graph, you're just given a couple of points that would be on a graph, but you don't have the ability to actually graph it. So then you're utilizing the slope formula to be able to identify what the slope is going to be between those 2 points. So since you have 2 points being provided for you, you do have a fraction, and the rise in this situation is going to be the change of your y's. So how do we figure out the change of our y's? We take our different y values, so y2, and we subtract our y1. Okay. And then for your run, it's the difference of your x values. So you take x2 and you subtract x1. And again, you are given 2 points. Okay, so given 2 points, where you have x1, y1, and x2, y2. So here's x1 with y1, and then you have your x2 paired with y2. Okay, they are 2 separate points from each other. Does it matter which point you label as your x1, y1 and your x2, y2? No. As long as you are consistent. If you decide that this is your x1, then that has to be your y1 with it. Okay, whatever is your first point, and then whatever is your second point. So you're taking your second point and subtracting your first. That's all you're doing. So if we're taking a look here at problem number 9, again, I have the point 1, 2, and I have the point -4, -3. It does not matter which one I label as x1, y1, or which one's x2, y2. Okay, I'm just going to go ahead and for the sake of consistency, I'm going to take that first point and let that be my x1 and my y1. And then let that second point be my x2 and my y2. And then I just substitute it into this formula. Now, one of the things I always tell students, set it up first, because I can't not tell you how many times people see the negatives and automatically think, oh, that's already there with my subtraction sign, so they drop the negative. By dropping your negative, it changes your answer completely. Okay, so I always say fill in your subtraction signs first, then fill in the points. So we know we're doing a y2 and a y1. Our y2 value is a -3. Our y1 value is a +2. Then at the bottom, I have to put my x2 value first, which was -4, and then my x1 value second, which is +1. The order that you subtract matters. If you change your order, it changes the answer. So be very careful. Okay. Once you go through and you start subtracting, you're going to wind up getting a -5 at the top for your numerator, and you're also going to get a -5 at the bottom for your denominator. And then you simplify. What's a -5 over a -5 going to be? +1. Good. So our slope is a +1. Okay? Negative over a negative is a positive. 5 divided by 5 is 1. Okay, go ahead and do problem number 10. What did you guys get? 1/2. Good. So if we're taking a look. Okay. So again, this could be my x1, this could be my x2, this would be my y1, this would be my y2. So then I'm just going to subtract. Y's go on the top, x's go on the bottom. Y's have to go on top, x's have to go on the bottom. So I'm going to do -2 minus -4. And then I'm going to do -3 minus -7. Okay? When I subtract those, I'm going to get a +2 for my numerator. I'm going to wind up getting a +4 for my denominator. And then when I simplify it, it simplifies to 1/2. Okay? You have a Delta Math that is loaded into Google Classroom. You are just doing 2 skills. One is to identify slope from graphs. One's to identify slopes from 2 points. Huh? Immediately. It's due at the end of class.